Hello everyone, so our question is two cylinders A and B fitted with piston with equal amount of an ideal diatomic gas at 300 Kelvin. The piston A is free to move while that B is held fixed. The same amount of heat is given to the gas in each cylinder. If the rise in the temperature of the gas in A is 30 Kelvin, then the rise in the temperature of the gas in B is. Okay, so we have been given two cylinders. One is having a piston which is free to move, and the another, that is the cylinder B, is having a fixed piston. Okay, now if we supply equal amount of heat in each cylinder, the rise in the temperature in the cylinder A is 30 Kelvin, then we have to find what will be the rise of the temperature in the cylinder B. Okay, now since the heat supplied in both the cylinders are same, correct, now cylinder A was having piston that is free to move, so it will heat at constant pressure. So the heat will be given as NCP delta T, and in the cylinder B the piston was fixed, so it will get heated up at a constant volume, so heat will be given as NCV delta T, correct. Now the number of moles in both the cylinder are same, so it will get cancelled out. So from here we get delta TB will be equals to Cp upon Cv times delta Ta. Okay, now Cp upon Cv is nothing but gamma times delta Ta. Now gamma for diatomic gas is 1.4, and rise in the temperature in the cylinder A is given to us as 30 Kelvin. So from here we get it as 42 Kelvin. So the rise in the temperature in the cylinder B will be 42 Kelvin. Now checking out from the options, we get our option number 4 is the correct option. Thank you.
Hey guys, the question is, when an ideal diatomic gas is heated at constant pressure, the fraction of heat energy supplied which increases the internal energy of gases. तो इसमें हमसे पूछा गया है कि डायटोमिक गैस को हम कांस्टेंट प्रेशर पे हीट करते हैं, सो वी नीड टू फाइंड द फ्रैक्शन ऑफ हीट एनर्जी सप्लाइड जो कि उसका इंटरनल एनर्जी बढ़ा देती है. सो प्रोसीड करते हैं. गैस इज डायटोमिक, मतलब इसका Cp होगा 7/2 R और Cv होगा 5/2 R. टोटल हीट एनर्जी सप्लाइड क्या होगा, mCp डेल्टा T. इंक्रीज इन इंटरनल एनर्जी होगा mCv डेल्टा T for m mass of gas. डेल्टा T है इंक्रीज इन टेम्परेचर, इंक्रीज और डिक्रीज इन टेम्परेचर. सो हमें निकालना है डेल U और Q का रेशियो, इंक्रीज इन इंटरनल एनर्जी और टोटल हीट सप्लाइड का. सो दैट विल बी mCp del T, so mCv del T और mCp del T के इक्वल दिस विल बी Cv by Cp. Cv और Cp की वैल्यूज रखते हैं 5/2 R और 7/2 R, ये होंगे 5/7. सो हमारा आंसर होगा del U by Q equals to 5/7.
Well, hello students, now we're going to see this question. The question says that an ideal monoatomic gas is taken a round cycle ABCDA as shown in the PV diagram. So this is basically the path followed by the work done. Okay, basically the work done during the cycle is, so we need to find the work done. So work done is basically what? In a PV diagram, work done in PV diagram, PV graph, let's suppose graph is area under PV curve. Okay, this is basically the area under PV curve. So what we'll get the basically the over here, what we can say over here is that the work done is basically what? The work done is this area. This square you can see over here, this area will be the work done of the thing. Okay, you must remember that the work done is basically the area enclosed by the cyclic thing in the PV graph only. Okay, only in the PV graph. So this is basically the work done area of this. So what will be the area basically of this? Let's write down now. Area will be equal to BA multiplied by BC. Okay, let's suppose not BC, let's suppose AD. Okay, because BC is equal to AD. So what we have basically, BA will be equal to, if we see over here, this is also point V, this is also V, means the x coordinate is basically, means y coordinate is basically same over here, but over here you can understand that this is V, so basically the x coordinate is same over here. Okay, where it is written afterwards, but it is basically representing the x coordinate. Okay, and P, you can see P changes from P to 2P, means the side has a length of basically 2P, basically not P, 2P minus P, which will be equal to P. Okay, so I'm writing over here, it will be 2P minus P, which will be equal to P. Okay, and basically this side you can see P is constant, but V is changing to 2V, so this side will be 2V minus V, which will be equal to V. So what we'll get basically, we'll get the area will be equal to P into V, okay, which will be equal to PV. Okay, so our answer is basically PV. So our answer is basically work done is equal to PV. Got it? Thank you.
हेलो फ्रेंड्स, इस क्वेश्चन में हमें 1 मोल ऑफ मोनोएटॉमिक आइडियल गैस जो अंडरगो कर रही है 4 थर्मोडायनामिक प्रोसेस वो डिस्क्राइब्ड है इस डायग्राम में। अब इन 4 प्रोसेस के अमंग एक आइसोबारिक है, एक आइसोकोरिक, एक आइसोथर्मल और एक एडियाबैटिक। हमें मैच करनी है लिस्ट 1 और लिस्ट 2 को कॉरस्पॉन्डिंगली। ठीक है, तो जो प्रोसेस 1 अगर हम देखें तो यहाँ हम देख रहे हैं एडियाबैटिक प्रोसेस, क्योंकि हमारा जो चेंज है क्यों है। ठीक है, यहाँ जो चेंज ये जो कर्व हमें रिप्रेजेंट करता है फर्स्ट, वो हमारा है एडियाबैटिक प्रोसेस कर्व। ठीक है, तो इसलिए हमारा जो हीट है वो 0 रहेगा। ठीक है, और जो प्रोसेस हमारा जो 2 है वो हमारा क्या रिप्रेजेंट कर रहा है इस लाइन पे, आइसोबारिक, क्योंकि प्रेशर कांस्टेंट है तो आइसोबारिक प्रोसेस हो गया, यानी कि जो वर्क डन है वो हो गया P डेल्टा V, यानी कि 6P नॉट V नॉट चेंज इन वॉल्यूम जितना आएगा। थर्ड में जो है हम देख रहे हैं वो हमारा क्या है, आइसोकोरिक, क्योंकि वॉल्यूम हमारी चेंज नहीं हो रही, तो इस केस में जो हमारा वॉल्यूम चेंज जो है डेल्टा V 0 हो गया, तो वर्क डन 0 है। और प्रोसेस अगर हम 4 देखें हमारा, तो उसमें हमें क्या मिल रहा है, आइसोथर्मल कर्व। तो ये हमारा हो गया आइसोथर्मल कर्व, क्योंकि इसकी स्लोप थोड़ी ज़्यादा है एडियाबैटिक कर्व से। ठीक है, तो अगर हम अपने ऑप्शंस एनालाइज करें तो जो सी है वो हमारा करेक्ट आंसर है, यानी कि थर्ड। पी जो है हमारा थर्ड ग्राफ है, यानी कि प्रोसेस 1 जो नो हीट एक्सचेंज, और जो क्यू है वो हमारा है 2, यानी कि आइसोबैरिक, यानी कि 4 वर्क डन जो है 6P नॉट, और आर जो है हमारा आइसोकोरिक, तो वो हमारा फर्स्ट है 0 हो गया वर्क डन, और लास्ट एस जो है प्रोसेस 4 वो हमारा है 2, टेम्परेचर जो है अनचेंज रहेगा क्योंकि एक आइसोथर्मल प्रोसेस है। थैंक यू।
Hello everyone, let us try to solve the given problem. So in the given problem it says 1 mole of a monoatomic ideal gas is taken along 2 cyclic processes as shown in the PV diagram. The processes involved are isobaric, isothermal or adiabatic. Then we have to match that which of these processes JEE the work done with their respective process, right? So we have to find the magnitude of work done in the respective processes. So let's start with the process FG. So let's start with the process FG, right? So FG, right? FG is an isothermal process. Why isothermal? Because we can see that the slope of isothermal is less than the slope of the adiabatic process. So this is an isothermal process. where the temperature is constant. And what is the formula for isothermal work done in an isothermal process? So WFG will be simply equals to nRT ln. Now let's put the values. So we do not know the temperature here, so in place of RT we can substitute the pressure and volume that we know. N is simply 1, and in place of RT we can write P naught V naught, since the temperature is constant, so simply we can write this is 32 times P naught into V naught. Now ln is 32 P naught divided by P naught, right? So this P naught and P naught will cancel. Ln 32 we can write, so we can take 2 here, 5 here, so this will be 5 into 32 P naught V naught ln 2, right? So this will be 2 to the power 5, so we have taken 5 here, so this will be simply equals to 160 P naught V naught ln 2. So FG matches with option P. So the work done in the process FG is 160 P naught V naught ln 2, right? So let's try to find out work done in the process G to E. So work done in the process G to E is simply, this is an isobaric process. So you can see that GE is an isobaric process where the pressure is constant and the volume is decreasing, we can see. So we can simply find out P dV. Now to find dV we need to know the volume here, so we can simply apply isothermal relation between F and G to find the volume here. So you can see that this is 32 times P naught V naught, this is equals to, so here we have to find volume. So the pressure is P naught and the volume, let us take this as V. So this gets cancelled, so what we get volume at G is simply 32 times V naught. So now we know the change in volume also. The pressure is P naught simply, and the change in volume will be simply, this will be final volume is V naught and the initial volume is, so you can see here that the work done will be simply minus 31 P naught V naught. This will be the work done in the process GE. Right, now we have to simply take the magnitude. So this will be WGE. We can take this as simply, if we take the magnitude, so this will be simply 31 P naught V naught. Now we have found out the work done in the process GE, and you see the work done in the process GE is simply 31 P naught. So this matches with H. Now let's try to find out the work done in the process F to H. Now let's try to find out WFH. So WFH, we can see that this is an adiabatic process, right? So for an adiabatic process, what we first need to know, if we apply the formula for work done, so this will be simply equals to P1 V1 minus P2 V2 divided by gamma minus 1. Now you can see that we know the P1 and P2, but we don't know V1, but we know V1, but we don't know V2. So first we need to find out V2, that is what is the volume here. So let us try to apply the adiabatic relation between point F and H to find out the relationship. So how do we apply? So we know that P1 V1 to the power gamma is equals to P2 V2 to the power gamma. So from here P1 is 32 times P naught. This is 32 times P naught, and V1 we know that this is V naught to the power gamma, and gamma is simply 5 by 3, since this is a 1 mole of. Now P2 is simply P naught. P2 is equals to P naught, and we have to find V2 to the power 5 by 3. So when we solve from here, what we get V2 is equals to 8 V naught. Now we know P1 V1, we know gamma, we know P2 V2. So if we find out the work done during the process FH, so when we substitute the values, so what we are going to get, so you can see I have substituted the values, and WFH I have found out to be 36 P naught V naughts. When we solve, when we put the values and solve, then we find out 36 P naught V naught. So let's see that in the process FH, so this is simply Q And now let's find out for the process G and H. So we have to find for the process GH. So this is the last process. Let's find for GH. So GH is again an isobaric process. So this is an isobaric process, right? So it is an isobaric process. So we can simply find out WGH. This will be equals to P times the volume is decreasing here again. So volume is decreasing. See, we can see in the process GH volume is simply decreasing. So at G we have the volume 32 V naught, and at H we have 8 V naught, and the pressure here is simply P naught. So from here what we are going to get, we are going to get 32 minus 8 is simply 24 times V naught. So we are going to get 24 P naught V naught. So this is the final answer that we had to get. So we have found out that the work done in the process G to H is 24. This is R. So this is the correct option. I hope you understood the explanation. Thank you.